All right, so I hope that you, particularly given the talks that you've heard so far this morning, I hope that you've got an impression that the NESP research has really provided a solid foundation for COTS control going forward, that we're achieving our outcomes at sites, at reefs, and across hundreds of reefs on the GBR at this point in time. It's a good outlook for the future, and what I'd like to say now is that if you've accepted all of that, I'd like to burst your bubble, and because I'd like to say that if we keep managing COTS according to the way we're doing it today, we will not meet the challenge of COTS control going into the future. And there are a range of reasons for this. The two most important ones, though, are really that there are essentially resource constraints associated with COTS control as we're currently doing it. And we are getting close to those constraints right now. So we can't keep adding reefs without, at some point, taking reefs off the back of the program. So we're going to have to learn how to do all of this a bit better. And then the other issue is for us that in the future, the problem that we're dealing with is going to change dramatically. So one of the things that we've been doing in the NESP program is not just trying to set up how to, to figure out and implement a control program, manual control program on the GBR, but also thinking about how we go about setting up the program so that it can adapt and evolve into the future. And some of the things that we're going to need to do are, first up, refine the control processes, the decision processes and the way we do our operations on the water. And in Cameron's talk, he went to a whole lot, introduced you to the details and talked about some of the evolution that's going to have to occur. We're going to have a much better decision-making process, make better decisions about revisitation rates, closure, about how we sequence particular reefs, how we distribute the fleet across the GBR. Critically, these cannot be just ad hoc changes. We can't just go, oh, this doesn't work quite so well, so we'll do it somewhat differently. These have to be changes that are made in a coordinated, a strategic way and within the context of the IPM so that we can evolve and monitor the effect of those changes in a structured way. The second thing is that there are opportunities for bringing some new technologies into the program, things like attractants to draw COTS in. Luna talked to some of those things in some of those opportunities in her talk. We need to explore those, adopt those, and introduce those into the program as appropriate. Then there are some new levers that we're not currently using effectively that we can start to think about how would we deploy things like fisheries management, the stuff that Frederica talked about. Those are important things, but one really big thing that we will need to do is to introduce a completely new component to the control program, and that's going to be a full-scale monitoring and surveillance program. We'll need to do that because at this stage of the game, monitoring and surveillance are focused on operations, and that question is going to be a subset of the total monitoring needs that we have. And I'm going to talk, most of this talk is going to be about those efforts. And Sven has talked to some extent about one of the technologies that's likely to be used in that context. And then the third thing is that you can't manage COTS if you don't have a reliable funding source. So we can do lots of research, we can implement all sorts of wonderful things on the ground. The next step is going to rely on the appropriate people making sure that there is a reliable ongoing source of funding for the control program into the future. So monitoring. This is going to be the biggest change. And a change that will effectively revolutionise what it is that we're doing in the COTS control program. If we're going to make smart decisions, appropriate decisions about how to distribute our resources across the GBR, we're going to need to know a hell of a lot of information about the distribution and the value of the assets and the threats that we're interested in. We're managing COTS because we want to protect coral, and that means that we need to know about the distribution of those coral assets across the GBR. We need to know where they are, which reefs have high coral or high asset value, and where those values are located on those reefs. And if we're going to make the best decisions, we need to have comprehensive information about that, i.e. we need to know about that stuff on all reefs, if at all possible, and across all reefs, at all reefs, across the GBR. That's the ideal situation, and we need to get as close to that as we possibly can. We also need to have similar information about crown of thorns, because that's the threat for those assets. And at the same time, we need to do the kind of monitoring of the control program that we're currently doing to allow us to assess its performance and its effectiveness, and to refine and improve it over time. Now, in the current program, we actually have a really simple situation. On the right-hand side there, you have the COTS, what I would term the outbreak cycle, where you go through an outbreak period, which, if we assume it's completely linear, which it may not be, but let's make that assumption for now. We start with a period where COTS are not outbreaking. We go through an initiation phase where densities build up and we start an outbreak. That becomes established and then spreads across the GBR before it collapses. In each of those phases, we need to have as comprehensive data set on the distribution and the value of our assets, the distribution and the magnitude of the threats that COTS are providing. And in the current program, we're really just thinking about that in this outbreak phase. We're really just thinking, we've got a good idea of where the outbreak is, and we're really just focusing on the control program progress and doing our best to make an assessment of where we need to go next. It's far more difficult once we move into the next outbreak. And in the next outbreak, our primary objective is going to be to reliably detect and delimit initiating outbreaks. And that's going to be a really difficult task, because we're going to have that comprehensive monitoring of COTS densities that will definitely right across the initiation and dispersal boxes that I outlined earlier, but potentially also at a much broader scale. The challenge is to be able to detect those initiating populations and respond to them in a timely fashion. Now, if we can do that, then job's done. That's really nice. But if we can't, then and we actually get an outbreak establishing, we then have to be able to delimit that outbreak and manage that outbreak, and hope, if not stop it, then at least try and suppress it as much as possible to limit the spread and minimise the impact on the GBR as a whole. And the challenge there for us is going to be distributing our control effort across the reefs in the most effective manner. So we're going to be dealing with potentially multiple phases of the outbreak at the same time, because, as is the case today, not all parts of the reef are outbreaking at the same time. And, that means our resources are going to have to be really widely distributed, both in terms of the surveillance, but also, if we can get our surveillance broadly distributed, then that will allow us to distribute our control effort most effectively. So our focus in the future outbreak is really going to be about getting good surveillance strategies and a rapid response in place, and then being able to assess control program performance as it goes on. And doing that in the context of ever-increasing resource constraints. So if we're going to be anywhere near successful in the next outbreak, we're really going to have an excellent monitoring program in place. But that's not going to be easy. In my previous talk, I identified that we really need to be focusing on detecting adults in the initiation phase, because they are the ones that we can manage directly. So I won't go into the details of that. I also outlined where I think our effort should focus, and I think we can't just focus on the initiation and dispersal boxes. We need to emphasise that area, but we can't be certain that outbreaks don't start elsewhere on the GBR. So we'll have a focus in that area, but We'll need to monitor other areas to a lesser extent as well. And it's not clear when the next outbreak would start. It may have started already, or it may start in 5 years or 10 years. Whenever, we have to have a process in place now, essentially, in order to be able to respond in a timely fashion. And we need to have a monitoring program and monitoring strategy that's able to respond to a whole, not just to these uncertainties, but to a whole range of other uncertainties. So, for example, what are we trying to detect? Well, we will expect that there are going to be COTS on reefs, right, in all of the different outbreak phases. It's not a matter of are they there or are they not there. We expect that there are COTS at most, if not all, reefs at all times. So, but what we really want to be able to do is to detect when COTS densities are leaving those baseline levels that we would have established during the inter-outbreak phase and are approaching those outbreak thresholds, the reproductive or the ecological threshold, whichever threshold's chosen. And one of the issues, though, is that we know that COTS distributions on reefs is not even. It's very patchy. Some spots have them, some spots don't. And we know that even in the peak area of an outbreak, that not all reefs are actually outbreaking. So we need to have a program that can accommodate that uncertainty in the distribution of an outbreak and at the same time be able to monitor the assets quite comprehensively. So even if we detect COTS approaching an outbreak threshold, we don't necessarily know that that's going to turn into an outbreak. There's been a lot of focus on what are the drivers of outbreaks, but very little focus on what's the pattern of outbreak formation. And that adds another layer of uncertainty because different models of outbreak evolution or initiation would suggest that we'd be looking for different patterns of COTS densities across the GBR. If it's just a point source, for example, at the extreme, it might just be one highly fecund female that starts an outbreak, then we're looking for a single female on the GBR, and that would require an enormous monitoring effort, needle in a haystack type stuff. The traditional model would suggest that it's something like water quality, which is likely to have a regional impact. And so under that scenario, you might expect that reefs across a region would behave in a coordinated kind of a way. And that might mean that you can use a much lower level of monitoring and surveillance in order to detect an outbreak. But an alternative model would be more of a metapopulation dynamics model, where you might expect that populations at a site on a reef or at different reefs might be doing their own thing, and that, you know, going up and going down in density, and that outbreaks form when you get synchrony within an area. So there might be different things driving the dynamics on individual reefs, but because they peak in synchrony, there's a sufficient density of COTS across those reefs to actually start an outbreak. And that implies a completely different sort of monitoring strategy as well. So one of the key things that we need is a really well-designed sampling strategy for how we go about monitoring the GBR, how we go about, and the things that we're measuring and the scale that we're measuring things on individual reefs, in order to be able to accommodate all of those different types of uncertainty that I've identified. We also need to have new monitoring tools. And Sven outlined the potential role of something like eDNA. There's also the role, you know, at the moment, the best monitoring tool that we have is the COTS cull program and the cull data that comes in from that program. But we will need, no single tool is going to provide the information that we need at all of the spatial scales that we need it at. And so we're going to end up having to design a monitoring program that can accommodate different types of data coming in, integrate that information, and in order to allow us to make inference about how we should distribute resources. So things like eDNA, things like image-based tow machines. Cameron identified some of those, Vertigo and Ames's reef scan technologies. Those are the sorts of things that allow us to monitor or conduct surveillance across entire reef perimeters, measuring not just COTS densities, etc., but also information about the coral assets that we have available to us. So we're going to have to develop these technologies, test their errors, and get them implemented in the field. We're going to need to use that information to better prioritise our reefs. I won't go into the detail there, but Cameron has identified, talked a little bit about the processes we currently use. Monitoring that provided comprehensive information about COTS and the coral assets would allow us to radically change and improve our prioritisation process. We'll also need new tools for making decisions about how we distribute our resources across the GBR. That's going to be fundamental. And again, Cameron talked briefly about the potential in the future there. All of this is going to flow through to new ways of how we operate on water. And I think the key change there is going to be around how we split the task. At the moment, the control vessels do both surveillance and control operations. And my thought is that in the future, what we'll see is that we'd like to see a separation of tasks where the broad-scale surveillance and monitoring is likely to be done by surveillance only, vessels that are tasked with surveillance only, splitting up that control and surveillance activity to some extent. So just quickly to wrap up then, I think one of the things that we've done in this, one of the important things that we've done in the NESP work so far is, as I said earlier, we've provided a foundation, COTS Control Program. And now what we've also done in a range of the reports and things that have come out is we've identified the pathway to actually make, not just to the pathway forward to a program that is able to meet the challenges in the future, not just a program that can meet the operational needs today, which is essentially what we have. It doesn't seem to matter what else happens out on the GBR, whether it's bleaching or cyclones or whatever. COTS will remain a major threat to hard coral on the GBR. And so COTS control is going to be fundamental to maintaining and supporting the resilience of the reef going into the future. We can be as smart and have as good a program as possible, humanly possible, operating on the GBR, but it's all for naught if we are not able to actually reliably fund that program going into the future, because that provides operational uncertainty that completely just knocks the wheels off all of the efforts that we can make. And so to all of the people who have influence at the funding decision level, my plea is really, if we don't get a solid baseline of funding going forward, all of this effort will have been for naught. Thank you.